So today we are going to present our demo for the project named shopping cart service on AWS, and we are going to show you the steps that we use to implement this project and a demo. Okay. So I would like to introduce my team. She is Snehal, Saili, Sachin, Shraddha, and Vijay. To start with the demo, we are going to create an account. Account is created successfully. Now we are going to sign in. Now here we can see the restaurants. Let us select one. So there are no recent orders as we are signing in for the first time. Now in herein we can add menu items to the cart. So I have added 2 items to the cart and the cart is showing total. Now we are going to check out. So cart added successfully into the database. Now when user logs out and try to sign in again, the user can see the recent orders. So this we are demonstrating using the Cassandra cluster, which shows the recent order, which is highly available and partition tolerant. Now here we are going to make another order and log out. So if we sign in, we can see the latest orders added to the recent item. Now we are going to demonstrate the CAP theorem in our project. To start with, we have created a cluster. So let us look at the Amazon AWS console.
To show the CAP theorem via MongoDB, which follows consistency and partition of the CAP theorem, our application is designed in a way where every write and read operation would be done via primary node. We'll be bringing down a primary node and one of our secondary would become primary. And then we'll be able to connect and do a read and write operations. So the data that we'll be fetching will be consistent, making sure that we don't get stale data. We demonstrated partition tolerance, saying that if one of the node is down, the application is still available to the user, and while connecting it, there would be some gap, which would mean that we compromised on availability. Now we have a new primary node created. So if
we sign in again, since the secondary node has become a primary now, we are able to sign.
Yeah, that demonstrating the consistency of a database. Thank you.
Project, we are using Redis for caching shopping cart details. When user clicks on Add to Cart, system stores the shopping cart details into the Redis. Record will not be stored into MongoDB database until the purchase is complete and only keeps orders in the DB. We have created Redis cluster on AWS. For 3 shards, it will act as a primary nodes and each shard containing 2 read replicas. Here we can see one instance on which Redis APIs are running and one Redis endpoint. A Redis server is running. Here we can insert the menu for the user Smita.
So, do you have any questions?
Yeah, how you are incorporating CapTheorem into it?
So,
Okay, I'll take this one. Mongo generally follows CP part of CapTheorem,
Okay.
and in the application, any read or write operation is happening via primary node. So to show that how CP is incorporated in this, we will bring down the primary node, and one of the secondary nodes will become primary,
Okay.
so that you get consistent information, and we show partition tolerance by bringing one of the node down, and we compromise on availability.
You compromise on that. Okay.
So in total we have 3 node cluster.
Yes. Good.
Okay, thank you.
thanks.